Hello my scholars, you are welcome to my school channel and my name is Frank. In this video, we are going to be tackling JAMB CBT past question for chemistry, year 2023. Please do not go anywhere, stay with us and we'll be right back. You are welcome back to my school channel. So in this video, we are going to be tackling question 1 to question 20. So let's kick off with question 1. What happens to the position of equilibrium if a reversible exothermic reaction is subjected to a decrease in temperature? So according to Le Chatelard principles, there are 3 factors that affect the position of equilibrium of a reversible reaction. Okay, and these are temperature, pressure, and concentration. Any change in 3 of these, okay, we disturb the position of equilibrium of the reversible reaction. So option C and D can never be any of the answer to this question. So let's go to option E. Now the position of equilibrium shifts to the left. Yeah, of course, the position of equilibrium shifts to the left if the backward reaction, okay, involves production of heat. Okay, but for this question, I think the forward reaction involves production of heat. So the position of equilibrium is going to shift to the right, okay, because the forward reaction involves production of heat. So according to Le Chatelard principle, the system will try in such a way as to adjust itself, okay, in order to annul the effect of this change in temperature. So option B is the correct option, okay, since the forward reaction involves production of heat. Question 2. Which noble gas is radioactive and is produced as a decay product of uranium and thorium? Okay, so A, we have argon, B, we have krypton, C, we have radon, D, we have neon. Okay, so argon, krypton, in fact, all the gas listed here are all noble gases. Okay, but argon is not radioactive, krypton is not radioactive, and neon is not radioactive. So that leaves us with radon. Okay, so radon is actually a decay product, okay, of uranium and thorium. So the correct option to this question is option C. Question 3. Which of the following reactions would be expected to have the highest entropy change? So entropy simply means degree of disorderliness or randomness of a system. Okay, of course, you know that the particles of gas are free to move about. Okay, but when a gas, let's take option C for example, when a gas is changing to liquid, definitely the movement of their molecules are reduced. Okay, but for option A, when a gas is, or when a substance is changing from liquid to gaseous state, definitely their molecules are free to move about freely. So the transition from liquid to gas involves more chaotic movement, okay, of molecules. Okay, and this leads to higher entropy. So option A is our answer. Question 4. What is the sum of the oxidation numbers in a neutral compound? So let's take a neutral compound for an example. Let's say water. So this is a neutral compound. Why is this a neutral compound? Because it is not carrying any charge. Okay, so we can say that the sum of the oxidation number of a neutral compound is equals to 0. Okay, or you can as well say that in a neutral compound, the sum of the positive charges is equal to the sum of the negative charges. So let's take this for example. Of course, hydrogen is positive here and oxygen is negative here. So what is the oxidation number of hydrogen? Is 1. Okay, but we are having 2 hydrogen atoms here. So this becomes 2. Okay, now what is the oxidation number of oxygen? Is actually minus 2. Okay, so plus 2 minus 2, that will be equals to 0. So the correct option is option C. Question 5. According to the kinetic theory of gases, the pressure exerted by a gas is due to A, we have vibration of gas particles, B, we have the weight of the gas particles, C, we have the attractive forces between gas particles, D, we have the collisions of gas particles with the container wall. Okay, so the answer to this question is option D. Okay, now the reason is because according to kinetic theory of gases, okay, the attractive force of attraction between gas particles are negligible. Okay, so these gases are free to move about, okay, colliding with one another and with the wall of the container in which they are in. Okay, and this force of collision produces the pressure, okay, that is exerted on the container. So option D is our correct option. Question 6. What is eutrophication? So eutrophication simply means the excessive growth of algae and aquatic plants in water body, okay, due to availability of nutrients such as phosphorus and nitrogen. Okay, so these phosphorus and nitrogen are actually produced as a result of industrial discharge into water body. Okay, and waste sewage too are also discharged into water body. These nutrients are made available for the growth of algae and aquatic plants. Okay, so the answer to this question is option B. The excessive growth of algae due to nutrient enrichment. Do you know you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and this will take you to my school website. There you need to download my school mobile app for your Android devices and my school software for your laptops and computer. Please go ahead and start practicing. Moving on to question 7. What is the name of the process by which ammonia is produced on an industrial scale? Okay, so let us go straight to the answer to this question. So the name of the process by which ammonia is produced on an industrial scale is known as Haber process. So in this process, nitrogen gas, okay, reacts with hydrogen gas to produce ammonia. Okay, but this had to take place in the presence of iron as a catalyst. Okay, so the answer to this question is option D. I believe you are enjoying these video lessons. If so, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get notified as soon as we release new videos. Question 8. Who proposed the planetary model of the atom with electrons orbiting the nucleus? So A, we have Erwin Schrödinger. Okay, so Erwin actually worked on the quantum theory. Okay, then B, we have Ernest Rutherford. So the concept of the planetary model of the atom actually started with Rutherford, but it was better explained, okay, by Nebor. So generally Nebor's model, or Nebor is accepted as the one who proposed the planetary model of the atom with electron orbiting the nucleus. So according to him, he said the electrons orbit the nucleus in the same way as the planet moves around the sun. Okay, why J.J. Thomson was the one who discovered electron. So the answer to this question is option C. Okay, the whole concept started with Rutherford. Okay, but it was properly explained by Nebor. Hence, the theory is credited to Nebor. So C is our answer. Question 9. Which of the following is an example of an endothermic reaction? What is an endothermic reaction? So, and the endothermic reaction is a type of reaction that occurs by the absorption of heat. Okay, endothermic reaction absorbs heat, okay, before they can take place. So option A, we have combustion of propane to produce carbon dioxide and water, which is not true. Combustion means release of heat. Okay, while B, burning of methane, okay, in the presence of oxygen, burning too also produces heat, it does not absorb heat. While option C, formation of table salt from sodium and chlorine, okay, that does not also involve heat. Okay, while D, decomposition of hydrogen peroxide into water and oxygen. Okay, so the correct option is option D, decomposition. Decomposition requires heat. Okay, hydrogen peroxide requires heat to decompose to water and oxygen. So example of an endothermic reaction here is option D. Question 10. What happens to the value of the equilibrium constant, Kc, for a reaction if the reaction is reversed? So A, it becomes 0, B, it becomes negative, C, it remains the same, and D, it becomes the reciprocal of the original value. So the answer to this question is D, it becomes the reciprocal of the original value. So let's move over to the board. Let me show you why option D is the correct option. So let's consider this reaction. A plus B Okay, it's a reversible reaction producing C and D. So if we are to write the equilibrium constant for this reaction, we'll be having the concentration of C times the concentration of D, okay, divided by the concentration of A plus, okay, times the concentration of B. Okay, so if we decide to revise the reaction, we'll be having C plus D, then forward and backward, that will produce A plus B. So if we write the equilibrium constant of this reaction, we'll be having concentration of A, then times the concentration of B over the concentration of C times the concentration of D. So as you can see on the board, the concentration of the reverse reaction is actually the reciprocal of the original reaction. Okay, so that validates the reason why the correct option is option D. Question 11. What is the chemical structure of soap and detergent molecules? So our soap and detergent actually have head and tail, chemical wise. Okay, so the head is referred to as hydrophilic head, while the tail is referred to as the hydrophobic tail. Okay, so when we say hydrophilic, philic means love. So when we say hydro, there we are referring to water. Okay, what that means is that the hydrophilic head interacts with water molecules. The hydrophobic tail does not interact with water molecule, but rather interact with grease and other stains. Okay, so the option to this question is option A. Okay, and it's very obvious: hydrophilic head and hydrophobic tail. Question 12. What is the solubility product constant, KSP, used for? Okay, so before we mention or state what the solubility constant is used for, first of all, let's know the meaning of solubility product constant. So solubility product constant is an equilibrium constant for the dissolution of solid substances in aqueous solution. Okay, and its value depends on temperature. Okay, the more soluble a substance is, the higher the solubility product constant. So this solubility product constant is actually used to measure or to calculate the concentration of solutes in a saturated solution, okay, where no more solute dissolves at equilibrium. Okay, so from what we have said, option B, okay, becomes the correct option to determine the concentration of a solute in a saturated solution. Question 13. Which trace gas in the atmosphere plays a significant role in the greenhouse effect? So first of all, let's understand the meaning of greenhouse effect. So greenhouse effects are actually caused by greenhouse gases. Okay, so what these greenhouse gases do is that they trap some heat radiated from the Earth's surface. Okay, thus causing the temperature of the Earth, okay, to be higher than the average or than the normal. Okay, so example of greenhouse gases are carbon dioxide, methane, okay, we have nitrous oxide, etc. Okay, so from explanation, we know that oxygen is not a greenhouse gas, argon is not a greenhouse gas, nitrogen is not, then our answer definitely is carbon dioxide. Okay, so the answer to this question is carbon dioxide, and carbon dioxide is also a trace gas in the atmosphere. Okay, even the same as argon, but carbon dioxide is the answer to this question. Question 14. Which of the following methods can be used to remove temporary hardness from water? Okay, we know that temporary hardness is caused by the presence of calcium, hydrogen, thiazocarbonate 4, okay, in water. So chlorination is not used in removing temporary hardness of water. Okay, chlorine is simply added to water to kill germs, so it's often used as germicide, okay, in water purification. Of course, sedimentation is not also used to remove temporary hardness of water. Okay, sedimentation is just a method of coagulating, okay, of gathering or of causing all the dead particles in water, okay, to gather in a spot. Then we have filtration. Filtration is actually used to remove solid particles from water. Okay, so we are now left with boiling. Okay, so the method that is actually used to remove temporary hardness of water is boiling. Okay, so we said calcium hydrogen triisocarbonate 4 is the salt, okay, of one of the salt responsible for temporary hardness of water. So let us boil. So when this is boiled, this salt will be broken down to calcium triisocarbonate and water and carbon 4 oxide. Of course, this calcium triisocarbonate is insoluble in water, which can be filtered off. Okay, so A is our correct option. Question 15. What is Faraday's constant? So A we have 6.00022 times 10 raised to the power 23 per mole. Okay, this is actually Avogadro's number, so this is not Faraday's constant. So option B we have 3.00 times 10 raised to the power 8. Okay, meter per second. I think this is talking about speed. This is the speed of light. Okay, while C is 9.81 meter per second square. This is acceleration due to gravity. Okay, while option D, that leaves us with option D, which is 96,485 coulombs per mole. Okay, so Faraday's constant is actually equals to 96,485 coulombs per mole. So what is Faraday's constant? Faraday's constant simply corresponds to the amount of electricity that can be carried by 1 mole of electron. So option D is the correct option. Question 16. A gas occupies a volume of 1.5 liters at a pressure of 2 atmospheres. If the pressure is increased to 4 atmospheres, while the temperature remains constant, what will be the new volume of the gas? Okay, so this question is a typical of Boyle's law. Okay, Boyle's law states that at constant temperature, pressure is inversely proportional to the volume of a given mass of gas. Okay, so let's move over to the board to calculate for the new volume. So applying Boyle's law, okay, P1 V1 is equals to P2 V2. And we know, okay, from what is given to us in the question that our P1 is 2, so we just substitute 2 times 1.5 is equals to P2 is 4, then, and V2, which is what we are looking for. So make V2 the subject of formula. So we'll be having 2 times 1.5 divided by 4, okay, and this will be equal to, okay, 2 here is 2, 2 here is 1. Okay, so 2 here will be, okay, so this becomes 3/2 divided by 2. Okay, so let's quickly do this, and this will be, this becomes 3/4, okay, which will give us 0.75 liters. So let's move over to the screen to pick the correct option. Okay, so from our calculation, the correct option is option C, 0.75 liters. Do you have any question to ask? Please feel free to ask your question by clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions and solution will be provided to you within a short period of time. Moving on to question 17. Stainless steel is an alloy made up of dash. Let's start with option D. So option D is iron and carbon. So iron and carbon is not stainless steel. Iron and carbon is steel. Okay, then let's move to option C. Option C is iron and chromium. Of course, stainless steel is iron and chromium with small amount of other elements such as nickel and molybdenum. Okay, then option B is copper and tin. Copper and tin we know is brass. And while A, iron and zinc is not stainless steel. Okay, so the correct option to this question is option C, iron and chromium. Do you have better explanation or steps in answering any of these questions? Please share this information with us by going to the comment section to comment the question number and the solution you wish to share. Question 18. What is the state of matter in which particles are widely spaced and move freely with high kinetic energy? So A, we have liquid. Of course, the particles of liquid are closely packed, okay, but they are not as packed as that of solid, so they are not free to move about as that of gases. So B, we know that the particles of solid are held by strong electrostatic forces. so that they are not free to move about. Okay, the particles are not evenly spaced. Okay, then option C, plasma. So plasmas are referred to as soup of positive and negative charges. So option D is gases. Of course, the force of attraction holding the particles of gases together, okay, they are not as strong as that of solid. Hence, they are free to move about, okay, with high kinetic energy, okay, and the particles too are evenly spaced, okay, they are widely spaced. So the answer to this question is option D. Question 19. Identify the reducing agent in the following reaction. So this is zinc reacting with copper 2 tetrasulfate 6 to give us zinc tetrasulfate 6 and copper ion. Okay, so we are asked to identify the reducing agent. Okay, but one thing we must know is that in a redox reaction, okay, the reducing agents are the ones that will undergo oxidation, while the oxidizing agents are the ones that will undergo reduction. So the reducing agents will be oxidized at the end of the reaction, while the oxidizing agent will be reduced at the end of the reaction. So we are going to answer this question based on oxidation number. Okay, so here we are asked to identify the reducing agent, and I said the reducing agents, okay, at the end of the reaction they will be oxidized, okay, and they are the ones that undergo oxidation, while the oxidizing agents are the one that undergoes reduction. So when you look at zinc here, the oxidation number of zinc here is 0, okay, because it's a neutral compound. But moving on to the product side, okay, the oxidation number of zinc here is 2, okay, and oxidation in terms of oxidation number simply means increase in oxidation number, okay, and we said that reducing agents, okay, are the species that will undergo reduction. Okay, so without wasting our time further, okay, the reducing agent in this reaction is zinc. So the correct option is option B. Question 20. Balance the following redox reaction. So ion 3 reacting with carbon monoxide to give you iron and carbon dioxide. So in balancing redox reaction or in balancing chemical equation, just make sure that the number of atoms of the element, okay, on the reactant side is equal to the number of atoms of element on the product side. Okay, so for this reaction we have iron, we have oxygen, we have carbon. Okay, so now let's just skim through the question. Let's see the one that is balanced. Okay, so let's check out option D. So for option D, we have 2 atoms of iron on the reactant side and 2 atoms of iron on the product side. So iron is balanced. Let's check for oxygen. So on the reactant side, we have 6 atoms of oxygen. So let's check on the product side. So on the product side, we also have 6 atoms of oxygen. Okay, 3 times O2, that will give us 6. While let's check out for carbon. So on the reactant side, we have 3 atoms of carbon. On the product side, we have 3 atoms of carbon. Okay, so the answer to this question is option D. Okay, in option D, the equation or the redox reaction is balanced. I believe you are enjoying this video content. If so, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.